Welcome to section 8.2, integration by parts, and this is the first day we're going to spend on it. So what is integration by parts and why do we use it? Well, let's look at our first example. If we wanted to use the product rule while integrating, right? How do we do that? We don't know. So that's where this integration by parts comes from. So the formula for integration by parts is if I am taking the integral of u dv, it's equal to u times v minus the integral of v du. Okay, so how does that help us? Well, first let's just go through the derivation of this formula and then we'll get to some examples. All right, so I want you to take a second, pause the video and make sure you get this all down. So if we're looking at the formula for the derivative of a product, right? So if I'm taking the derivative of u times v, we know it's u times the derivative of v, which is dv dx, plus v times the derivative of u, or du dx. So we can rewrite this as u v prime plus v u prime. Okay, so this is where both u and v are differentiable functions of x. If u prime and v prime are continuous, you can integrate both sides. Okay, so now we're going to integrate. So we're going to take the integral of this left side here, and we're going to take the integral of that right side there. Okay, so what do we get? Well, taking the integral of the left, we're just left with that aspect there. Taking the integral of a derivative is just u times v. Integrating u times v prime dx, we would just call that dv, plus v times u prime dx, we'll just call that du. So what we have is u times v is equal to the integral of u dv plus the integral of v du. So what we just want to solve for is we're solving for this guy, and we're just going to subtract the integral of v du. So we get our formula. Okay, so this is our integration by parts where we're thinking u and dv are the product, all right? F of x times g of x. All right, so when we are figuring out the parts that we want to use, we always start by picking u, and we want to choose a u such that it makes du simpler. Okay, and you'll see what I mean when we go through some examples. So again, make sure you get this down, and then we'll move on to the first example. Okay, looking at this first example, we want to integrate x times e to the 2x dx. Now, if we just did a straight u substitution, we would probably say u is 2x, but then we still take the derivative and we don't have this x here. So what do? Well, this is where we use those integration by parts. So if I let u be x, because remember, we want to choose a u that makes du simpler. Well, by taking the derivative of x, we're left with du is equal to dx, okay? So then that means if this portion is our u, then this portion is our dv, okay? So we're really taking the integral of u dv, okay? So now, dv is e to the 2x dx. So now we need to figure out what v is by integrating this guy. So taking the integral of e to the 2x dx, you can do your u substitution if you need to, but in the end we get 1/2 e to the 2x. Hopefully we can jump to that pretty quickly. Okay, so now we have our u, our v, our du, our dv. We can go ahead and use our integration by parts. All right, so this is our original integral, and like I said, we're going to break it up as the integral of u dv, okay? And this is our formula, equals uv minus the integral of v du. So now we just make our substitutions. So u is x, v is 1/2 e to the 2x, minus the integral of our v, 1/2 e to the 2x, du, which is our dx. And now we just clean it up. So we can integrate this pretty easily. All right, we take the 1/2 out using a u substitution, and then integrating this portion, we're left with 1/2 e to the 2x. Since this is not a definitive integral, we are going to add that plus c, and now we can just clean it up. Now I factored out an e to the 2x over 2. I could also factor out e to the 2x over 4, and we would get this here. Either one is fine, and there we have it. Okay, I want you to try example B on your own. okay, the integral of cosine of x times x dx. So the hardest part sometimes is figuring out what your u and your dv is. So remember, you want to pick a u that makes the du simpler. So I'm going to give yourselves a second. Try that. Come back and check when you're done. Okay, so did you let u be x and dv be cosine of x dx? If you did, that's going to make life a lot easier. So then du is going to be dx, and v is going to be the integral of cosine of dx, and we just get sine of x. All right, so now go ahead and plug it into the parts formula and clean it up and see what you get. Check back when you're done. Okay, so if we let it be u times v minus the integral of v du, we make our substitutions. Integrating sine of x, remember to change that to a plus, cosine of x plus c. Hopefully you got that. Okay, this side we're going to deal with a few special cases, I guess, all right, and when we would use parts versus straight integration versus use substitutions, okay? So if we're looking at the integral of ln of x dx, well, we don't know how to integrate ln of x. So this is a perfect opportunity to use parts, okay? So if we let this guy be our u, then this be our dv, okay? So if that's the case, then u is ln of x. We know how to take the derivative of ln of x. We just don't know how to integrate it. So du is going to be 1 over x dx. If dv is dx, then we're integrating dx and we get x. So now that we have our parts, I want you to go ahead and finish off this problem. Check back when you're done. Okay, so making our substitution using the parts u times v minus the integral of v du, we have ln of x times x minus the integral of x times 1 over x dx. Well, this simplifies to just being the integral of dx. So we can integrate that easily, and don't forget your plus c at the very end. So now we're able to integrate ln of x. This next example deals with repeating or possibly having to use parts more than once. So if we take a look and we're integrating x squared times e to the 2x dx, again, we want to choose a u that makes du easier. So if we let u be x squared, then du is going to be 2x dx. If we let dv then be the rest of it, e to the 2x dx, then integrating that, we're left with 1/2 e to the 2x. So using our parts, we can go ahead and make those substitutions, all right? But what we notice, or what we should notice, is that when we clean this up here, so the integral of 1/2 e to the 2x times 2x dx, well, the 1/2 and the 2, they're going to cancel, and we're left with x e to the 2x dx. Well, we still have a product, right? And if we did a u substitution, it's not going to help us. So we need to use parts again on this integral. So if we go back over here, I'm going to let u be x this time. That's going to make du much simpler. If dv is still e to the 2x, that should say dx in there. Then v is going to be 1/2 e to the 2x. And now we can use parts again over here. So we just rewrite that first part, 1/2 x squared e to the 2x minus this quantity because we're subtracting this integral. Our u is x, v is 1/2 e to the 2x minus the integral of v du. And now this is much simpler. We can go ahead and integrate this guy here, no problem. We were able to eliminate the product within the integral. So cleaning everything up, we still have that first term. We cleaned up this second term, integrating 1/2 e to the 2x minus a negative. Make sure you change that sign to a plus. All right, 1/2 times 1/2 e to the 2x. Don't forget your plus c. We can factor out a 1/2 e to the 2x, and we'll be left with x squared minus x plus 1/2. Again, don't forget your plus c. Okay, this last example is called a recursive example. So what does that mean? Well, let's walk through this example and you'll see what I mean. So the first thing I notice is we have a product of two functions, right? And I can't make a u substitution, so parts it is. So now which one's going to be a better u? Well, if we let u be cosine of x, then du is negative sine x dx. At least there's some change, right? Okay, if dv is e to the x dx then v is e to the x. Okay, well, let's see where that gets us. All right, so we know it's u times v minus the integral of v du. Okay, so making our substitution, u is cosine of x times e to the x minus the integral of v du, e to the x times negative sine x dx. Okay, so now we are looking at just cleaning up this integral. We have the integral of e to the x sine of x dx. Notice that my sign has changed, minus and then this negative sine of x. Okay, but again, we have a product of two functions. I can't make a u substitution, so we need parts again. All right, so if we use parts again, I'm going to let u be sine of x again, or sine of x, okay, because then du is cosine of x, which will in turn help us, okay? You'll see why in just a second. So dv is e to the x dx, and v is going to be e to the x. So if we go through and we use those parts and clean things up with the second portion, let's just see where this gets us, okay? All right, so we have u times v minus the integral of v du, okay? All right, but what we should notice is these guys, the original integral that we're trying to find, matches with the integral the second time around. So that's a good thing, okay? So since those match, we're able to then add that integral to both sides, okay? So we add the integral of e to the x cosine of x dx to both sides of the equation, all right? And what does that get us? Well, now we have 2 times the integral of e to the x cosine of x dx equals e to the x cosine of x, that's this guy here, plus e to the x sine of x, that's this guy here, and don't forget about the plus c. So remember, we're just trying to solve for what this integral is equal to. So if we simply divide by 2 on both sides, we will get this integral on the left all by itself, cleaned up, e to the x over 2 times the quantity cosine of x plus sine of x plus c. So sometimes you have to use parts multiple times, okay? And as you're going through, recognize if that integral actually matches what we're originally trying to find, okay? And when do you use parts? Well, you use parts when we're trying to integrate a product of two functions where a u substitution is not possible, okay? If you have any questions, let me know. We'll get lots of practice in class.